All right, guys, let's get right into it. I think this is going to be a pretty short one because I think you guys are pretty good about standard and scientific notation. So, what is standard notation? So, standard notation is what you guys have seen for a while. Um, Here's standard notation 3.1415, some random number 782. I don't know, maybe you have a special number that you really, really love, 667. Who knows? Something like that. That's standard notation. What is scientific notation? Scientific notation is in this form, guys, where B is a number between 1 and 10. Like 1, well, I guess that's just right? 1.3 times 10 squared, 1.5 times 10 to the negative 5, 7.8 times 10 to the 12. All those are scientific notation, where B is a number between 1 and 9.9, 9.999, or 1 and 10. So yeah, so there it is, guys. So it says, all right, that was straightforward. I remember doing this when you were in junior high. Sorry, guys, I just had some noodles and they're coming back up. It said, so what's so special about the number 10? All right, so let's observe something, guys. It's easier to see with the positives. 10 squared is 100. 10 cubed is 1,000. 10 to the fourth is, let's see, 10 times 10 times 10. That's going to be 10,000. And you can see, so if I have 4 there, I have 4 zeros there. 3 zeros, 2 zeros. And let's see, why does my pen not want to work? 10 to the negative 1, that's going to be 1 over 10, which we know is 0.1. 10 to the 0, that's just going to be 1. So 10 to the negative 2, that is 0.01. And then the way I got that, guys, is because 10 to the negative 2, if you do in your laws of exponents, is 1 over 10 squared, which is 1 over 100. So 1 over 100 is equivalent to 0.01. So yeah, so this is why the 10 is so special, guys, because we can pretty much show any number with any of these things here. So for example, it says here, okay, Chav, how do I convert? I'm going to convert all these numbers in standard notation to scientific notation. So let's start with the 782 and the 67. Well, we just said that 10 squared is 100, guys. So I can say, let me put this right here. I can say 7.8 times 10 squared. 7.82, sorry. Times 10 squared will give me the 782, because that's the same thing as saying 7.82 times 100, which is 782. And so the same thing with the 667, guys. I can say 6.67 times 10 squared, and that will give me the 667. Now, in case you're wondering, like, Chavez, I don't see it. I have no idea. So imagine a decimal being right immediately after the 7 here. So how many times do you got to move it to have it located right in between the 6's? So 1, 2. You moved it twice to the left, so notice there's a 2 there. Same thing with this 2 here. How many times do I got to move it? So this decimal will be between the 7 and the 8. 1, 2. So there's a 2 here. I don't know why I did that. All right, let me disconnect it because maybe it's getting a little warm here. All right, so what about, Chavez, what about the 3.1415? Well, you don't need it, guys, because that's 3.1415, but if you're forced to write it in scientific notation, it would look like this. 3.1415 times 10 to the 0, because remember, 10 to the 0 is just 1. So if I want to explain, okay, 0.00032. So how do I do that one? Well, that's a pretty small number magnitude-wise. It's pretty close to 0. So it's going to be a negative exponent. And the way you do that, so here we go. I'm going to write it out first and I'm going to explain it. 3.2, then 1, 2, 3, 4 times 10 to the negative 4. So the way we did this, guys, the way I did it is this. I saw that decimal here, and then I imagined, okay, how many times would I have to move that decimal for it to be between the 3 and the 2? And it would be 4 times. So check it out. Let's count with me. 1, 2, 3, 4. See? So I would have to move that decimal 4 times. So that's the equivalent of 10 to the negative 4. In case you're wondering, Chavez, what is 10 to the negative 4? 10 to the negative 4 is, let's see, 0.0001. See, if I move that decimal 4 times to the right, 1, 2, 3, 4, that becomes a 1. Anything times 1 is itself. I hope that makes sense to you guys. So 3.2 times 10 to the negative 4. If I were to ask, what is this in standard form? I'm not asking for it, but if I were to ask you to write this in standard form, you would just count. You'd say, okay, I'm going to write 3.2 first, and I'm going to erase the stuff that I'm going to do. That's just negative 4. So that means I'm going to have a smaller number. So I'm going to go to the left. 1, 2, 3, 4. Every time you see one of those little dimples, you put a 0. And then decimal. And there it is. And I'm going to erase this, and I'm going to erase that decimal there, that's right here. And there it is, 0.00032. And sure enough, I have 0.00032 up there. See, so it's not that bad, guys, to go back and forth. It's very easy to go back and forth. So let's go ahead and transform these scientific notation into standard form, because we already went ahead and take care of all these. So 1.3 times 10 squared. So let's see, 1.3, and let's see. Well, you know what? Let's just write it out. 10 squared is 100. Move that decimal 2 times to the right. 1, 2. So that would be 130. This is the same thing as saying 1.3 times 10 squared. All right. What about the 1.5 times 10 to the negative 5? So imagine that decimal here and moving that 5 times to the left. 1, 2, 3, 4, 5. It looks like I'm going to have 4 zeros in front of that. So I'm going to write 0, 1, 2, 3, 4, and then 1, 5. That is equivalent to 1.5 times 10 to the negative 5. See, guys, it's not that bad. 1, 2, 3, 4, 5. Yep, we got it. We got it right. All right, last one, 7.8 times 10 to the 12. All right, so if I were to move that decimal 12 times to the right, I would have that 8 followed by 11 zeros. So here we go, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This guy right here, notice that's a huge number. That is 7.8 times 10 to the 12th power. All right, I hope you guys saw how we convert from either standard notation to scientific or scientific to standard. My apologies if it's not like super organized, but I hope that made sense. All right, how do I multiply? This is actually pretty simple, guys. Don't make this harder than it is, because, okay, let's just talk real quick rules. 5 times 3 times 2 is the same thing as saying 3 times 5 times 2. It doesn't matter the order. It doesn't. 5 times 3 is 15. 15 times 2 is 30. 3 times 5 is 15. 15 times 2 is still 30. Maybe I should have put the 2 in the front. 2 times 3. 2 times 5 times 3. Excuse me. 2 times 5 is 10. 10 times 3 is 30. See, we did it 3 different ways. We got the same answer all the time. So I'm going to be very careful here not to do linkage errors. So all this is just being multiplied. So this is just like saying 5 times 10 to the negative 4 times 8 times 10 to the 7th. And what I'm going to do is I'm going to group them, guys. I'm going to group this 5 and 8 because it doesn't matter where, how I multiply. So I'm going to group it like so. See? And then all you do now, what is 5 times 8? Yeah, it's 40. So you just write 40 times, and then this right here, that's just law of exponents. If you remember correctly, x squared times x cubed, that was just x to the 5th. See? You just add your exponents. So I'm doing the same thing here, guys. That's a 10. That's a 10. I have the same base. I'm just going to add the exponents. So negative 4 plus 7. Let's see. 7 minus 4. 1, 2, 3, 4. That's to the 3rd power. Times 10 to the 3rd. But I want to write this in scientific notation. I notice that's 40 here. Well, 40 is the same thing as saying 4.0 times 10. Yeah, 4 times 10 is 40, guys. Or you can just move the decimal there. If move that decimal there 1 time to the left, and you'll see that it's just 4.0 times 10 to the power 1. And then I'm going to multiply by 10 cubed. Again, 4.0 times 10 to the 3rd. That's like a power 1 there. And I'm going to add these two exponents, guys. So 4 times 10 to the 4th. And we are done. Hopefully that made sense to you guys. And yeah, it was that simple, guys. All right, let's continue. Okay, what about dividing? All right, don't freak out. So here's how we're going to do it. It's pretty much the same. It really is. So I look at that 4 and I say, hey, wait a minute. That 4, while it doesn't go into 2.4, if I move that decimal one time to the right, 4 goes into 24, guys. So I'm going to move that decimal one time to the right. So I'm going to say this is the same in the top as 24 times 10 to the 10th power. Because remember, that 11th means that you move that decimal 11 times to the right. Well, if you already moved it one time to the right, well, then you only got 10 more movements. So it's to the 10th power. I hope that really made sense to you guys. Rewind it again to hear it again. Well, you know what? I'm going to repeat it. If I move this decimal one time to the right, you're going to subtract from that exponent. Because remember, that exponent means that I moved that decimal 11 times to the right. And you just moved it one time. So you got 10 left. So there it is. And I'm dividing this by 4 times 10 to the 14th. Well, how many times does 4 go into 24? Let's see, 4, 8, 12, 16, 20, 24. It happens 6 times. So 6. And then look at this, just laws of exponents. So remember, when you had your algebra days, I'm going to say x to the power n divided by x to the power n. That was just x to the m minus n. That's just from your rules, laws of exponents. So that's all I'm going to do, guys. 10 minus 14, that's going to be negative 4. So I'm going to write times 10 to the negative 4. And you're done. That's it. If you want to write 6.0, that's fine. 6.0 times 10 to the negative 4, and you're done, guys. All right, let's do some problems. Okay, relax. We're going to try really hard not to do a linkage error. I'm going to do that part first because it looks like something's going to happen there. So I'm going to write, let's see, I'm going to write it like this. I'm going to write 5 times 8 times 10 to the 4th times 10 to the negative 2. And I still have that plus 706. So I'm going to write plus 706. So there it is. All this right here, I can just rearrange it how I please as long as I'm still multiplying and everything else is still multiplying. Why did I choose 5 and 8 again? I don't know. 5 and 8 just came natural to me when I was typing out these notes. All right, so 5 times 8, again, that's 40. 40 times, and then this right here is 10 squared, 4 plus a negative 2, right? And then I have plus 706. Well, 10 squared, let's see, 10 squared is 100. Do I want to multiply 4 times 100? I don't know, if you want to do this as 4.0 times 10 to the 1 times 10 squared, I think that might be easier, guys, maybe. All I did was convert that 40 to 4.0 times 10 to the 1 right here, this part. And then now I'm going to combine those exponents, guys. So 4.0 times 10 to the 3rd plus 706. Now, remember what 10 to the 3rd was. That's just 1,000 from way over here, guys. From, where are you? From right here. 10 to the 3rd is just 1,000. So, if I take a number like 4 and I multiply by 1,000, that's 4,000. And then I'm just going to add 706 to it. So that is 4,706. But it says to leave in scientific notation. So here's my decimal. I'm going to have to move it 1, 2, 3 times to the left. So 4.706 times 10 to the 3. I hope that made sense, guys. All right, let's see this one here. It looks like there's some stuff going on this one. I'm going to expand the numerator. And I'm going to put that one in scientific notation. So let's see, 6, 7, 8, 9 minus, and I'm going to move, that says 10 cubed, so if I move that decimal 3 times to the right, 1, 2, 3, 4,321, and all this is divided by, let's see, 1, 2, 3, 4, 5, 6, 4.0 times 10 to the negative 6. Don't worry, guys, in a little bit I'll change the numerator to scientific notation. So let's see. Let's subtract here. If I subtract 679 minus 4321, let's see, 9. I'm going to get 2, 7, 1, 2, 3, 4, 8 minus 2, 6, and 9 minus 1, 8. all over 4.0 times 10 to the negative 6. And I mean, it looks tough here, but it's not that bad, guys. Does 4 go into 2468? I think it does because of that 4. So let's focus on this right here. Now, we don't have a calculator, guys. I think we don't need one. I think we'll be fine. So let's see. 4 goes into 24. 4, 8, 12, 16, 20, 24. 6 times. I put 24 down there, and I zero that out. And we could probably figure out how many times 4 goes into 68, but I'm not going to do that. 4 goes into 6 one time, put a 4. That's 2, and then bring the 8 down. And then 4 goes into 28 7 times. So there it is, 617. So I can rewrite this as 617 over 10 to the negative 6. And again, 617 is the same thing as saying 6.17 times 10 squared. See, I move the decimal times 2 times to the left over 10 to the negative 6. I bring this back up, guys. So 6.17 times 10 squared times 10 to the 6. My exponent turned positive because I brought it up. And then we just add them up. So let's see, 6.17 times 10 to the 8th. And there it is, guys. Not too bad, not too shabby. All right, hopefully you guys enjoyed this. Give it a thumbs up, preferably. And I guess if you didn't like it, I mean, you can get a thumbs down if you want, but don't do that. All right, later, guys. Have a good one. Bye.